Welcome to the DIY Honda Garage channel. The diagnostic trouble code P2127 specifically pertains to the APP, Accelerator Pedal Position Sensor B, which is responsible for sending signals regarding the position of the accelerator pedal to the Engine Control Module, ECM, or Powertrain Control Module, PCM. This sensor plays a crucial role in optimizing engine performance and fuel efficiency by ensuring proper throttle response. For the Honda Civic models between 2006 and 2011, the APP Sensor B is typically located on the accelerator pedal assembly within the vehicle's footwell. Proper function of this sensor is vital for safe vehicle operation, as it directly affects the power and responsiveness of the vehicle. A reported low-voltage condition in this circuit may lead to performance issues or even impede the vehicle's ability to accelerate correctly. The knowledge of this code is imperative for effective diagnostics and repairs, as it provides a clear direction for troubleshooting. The error code P2127 indicates that there is an issue with the APP Sensor B, specifically related to a low-voltage signal being reported to the Engine Control Module, ECM, or Powertrain Control Module, PCM. This APP Sensor B, also known as TP Sensor E, is integral for accurately detecting the position of the accelerator pedal during vehicle operation. In the context of the 2006 to 2011 Honda Civic, this sensor can be found on the accelerator pedal assembly itself, nestled within the footwell. When the value detected by this sensor falls below approximately 0.2 volts, it indicates a potential malfunction in the sensor or its connections. As this system directly influences how the engine responds to driver input, any issues can lead to reduced performance, increased emissions, and may trigger various warning lights on the dashboard. Understanding the context and implications of this DTC is vital for a comprehensive troubleshooting approach. Several factors can lead to the activation of diagnostic trouble code P2127, each contributing to the low voltage condition detected at APP Sensor B. Firstly, a faulty APP Sensor B itself may fail to properly generate and communicate the required voltage, indicating a need for replacement. Secondly, issues with wiring such as frayed or damaged wires may disrupt the voltage signals transmitted between the sensor and the ECM/PCM. The condition of connectors plays a significant role as well. Loose or corroded connections can create intermittent contact, leading to erroneous voltage readings. Each of these possible causes is crucial for technicians to evaluate during the troubleshooting process, as accurately diagnosing the origin of the fault will guide the necessary repairs. It is essential to methodically inspect the sensor and its associated wiring and connections to ensure proper functionality. The presence of diagnostic trouble code P2127 can manifest in multiple symptoms that directly affect vehicle performance and drivability. One of the primary symptoms noted is erratic throttle response. The vehicle may not accelerate smoothly or may lag when pressing the accelerator pedal. Additionally, the check engine light, CEL, will likely illuminate on the dashboard, signaling that there is an issue with the vehicle systems requiring attention. Drivers may also experience reduced engine performance, characterized by sluggish acceleration or a feeling of hesitation when attempting to increase speed. It is essential for vehicle owners to be aware of these symptoms, as they could indicate a serious problem affecting the overall functionality of the vehicle and safety during operation. Recognizing these signs early and addressing them promptly through diagnostic practices is crucial in maintaining optimal vehicle performance. The first troubleshooting step involves turning the ignition switch to the on position, also known as position 2. This action serves as a preliminary setup that allows various vehicle systems, including the APP Sensor B, to power up and function correctly. Using the HDS, Honda Diagnostic System, the technician will check the voltage output of APP sensor B. According to diagnostic data, if the voltage reads approximately 0.2 volts or less, this indicates a potential fault within the sensor or associated wiring. Should the reading show a higher voltage, it may suggest an intermittent failure, and the technician should proceed to inspect the connections at the APP sensor and the ECM/PCM for poor connections or loose terminals. This initial step is crucial as it helps in identifying whether the system is functioning normally or if further investigation is needed based on the voltage readings observed. In the second troubleshooting step, the technician must turn the ignition switch to the lock position, which is the off state. Following this, the APP sensor 6P connector needs to be disconnected for further analysis. With the ignition back in the on position, it's necessary to measure the voltage between terminals number 5, SG5 light blue wire, and number 6, VCC pipe, gray wire, of the APP sensor 6P connector. A reading of about 5 volts indicates that the supply voltage provided to the sensor is adequate. If the voltage is present at this level, the troubleshooting can continue by moving on to further steps in the diagnostic process. Conversely, if there is no voltage at this level, this signals that there could be an extensive issue, which would lead to the need for more detailed diagnostics to be carried out, particularly looking into potential wiring issues or supply voltage problems. This step begins with the technician turning the ignition switch back to the lock position to ensure that the system is off and safe for further work. The next procedure involves jumping the SCS service check socket line using the HDS tool. This function helps prepare the diagnostic tool for checking the connection status with the ECM or PCM. Following this procedure, the technician must disconnect connector A from the ECM/PCM, which consists of 44 pins. This step is crucial as it allows the technician to assess the continuity of the circuits without interference from the ECM or PCM. Continuity testing will help determine whether any wiring issues exist between the APP sensor and the ECM/PCM. Maintaining safety is paramount during this process, ensuring that all electrical systems are properly managed and isolated before proceeding. In this step, the technician will check for continuity between APP sensor 6P connector terminal number 4, APS-B purple wire, and body ground. This is a critical test to confirm whether the ground connections are intact and that there are no breaks or faults in the wiring leading to the APP sensor. A successful continuity test confirms that the electrical path is complete and indicates the APP sensor can correctly communicate its position to the ECM/PCM. Conversely, if continuity is absent, it signifies a potential short in the wiring between the sensor and the ECM/PCM, meaning further investigation is necessary. Identifying ground issues is essential, as they are a common cause of sensor malfunctions, often leading to the low voltage condition indicated by DTC P2127. Correcting this aspect could resolve the trouble code effectively. The final troubleshooting step involves connecting APP sensor 6P connector terminal number 4 to body ground using a jumper wire. This procedure serves as a diagnostic method to evaluate if the APP sensor functions correctly when given a direct ground signal. If the sensor operates as it should in this configuration, it may indicate that the original issue was indeed with the wiring or connections, which directly impacted the sensor's performance. On the other hand, if the sensor does not respond appropriately, it suggests that the APP sensor itself is either defective or there are deeper issues concerning the voltage supply. This step is crucial in confirming the integrity of the APP sensor under different conditions, either paving the way for repairs or necessitating a replacement in line with the identified faults. After repairs have been completed to rectify the issues associated with DTC P2127, it is imperative to conduct a thorough verification process to ensure that the repair has successfully resolved the problem. Technicians should begin by reconnecting all the sensors and ECM/PCM connectors that were previously disconnected during troubleshooting. Following this, the ignition should be turned to the on position to power up the system. The HDS needs to be employed again to clear any stored codes, including the P2127 code. After clearing the codes, the technician should perform a road test or simulate conditions to ensure that the system is functioning as expected without triggering the trouble code again. A successful verification will confirm that the repairs made are effective and the vehicle is operating within its intended parameters. This step is essential in providing customer assurance that the vehicle is now in proper working condition. Preventive maintenance is a key aspect of vehicle ownership, particularly regarding electrical components such as the APP sensor. Regularly checking the wiring integrity and connections associated with the APP sensor can help mitigate future issues, such as the one signaled by DTC P2127. Technicians should recommend inspecting the wiring harness for any signs of wear, corrosion, or fraying that could lead to electrical malfunction. It is equally important to check the connectors for tightness and cleanliness to ensure a reliable connection is maintained. While no specific preventive maintenance tasks are mentioned in the context of this DTC, integrating these practices into routine vehicle service can significantly enhance overall reliability and performance. Customers should be informed of these preventive measures to foster proactive care for their vehicles. In summary, understanding DTC P2127 and its implications for the Honda Civic from 2006 to 2011 is crucial for effective troubleshooting and repair. The role of the APP Sensor B in managing throttle response cannot be overstated, as it has a direct impact on vehicle performance and safety. Technicians must follow a systematic approach to diagnose and address the issue, ensuring that all wiring, connections, and the sensor itself are thoroughly inspected and tested. The emphasis on preventive maintenance cannot be overlooked. Routine checks can help prevent future occurrences of this diagnostic trouble code. By fostering awareness among customers about how to care for their vehicle's electrical components, the likelihood of similar issues arising can be substantially reduced. Comprehensive understanding and actions are vital in maintaining vehicle functionality and reliability. Please like and subscribe to the channel. See you next time.